Okay, so now we are going to extend the previous session. So previously we have seen the type deep learning overview. So our topic was adversarial machine learning. So in that we are going to see the deep learning overview, and these are the topic we had a discussion in our previous video. So we had discussed about the machine learning basics, its types, and supervised learning, unsupervised learning, k nearest neighbors classifier, everything. So now we have seen the introduction of computer vision task. So computer vision task is nothing but, here you can see we are classifying a single object. Here we are classifying the multiple objects. So next thing we are going to see the machine learning with deep learning. Okay, so deep learning is a subsector of machine learning. So we can't think like machine learning is exactly opposite to deep learning. We can't compare it equally. So machine learning, inside artificial intelligence, machine learning is a sector, and inside machine learning, deep learning is a subsector. So now you can see the basic diagram difference. In machine learning, you have to give the input image and you have to extract the features. Then you need to do classification operation. And finally, you are going to predict it whether it is a car or not. In deep learning, the feature extraction and classification are integrated together. So here machine learning, as I told, that deep learning is a subset of machine learning. So in this diagram, what they are considering is nothing but other algorithms apart from the deep learning concept are considered as machine learning, like SVM, naive Bayes. Those things you can consider under machine learning algorithm. So deep learning. So deep learning is nothing but, you can see here, it's a machine learning subfield, and they uses multiple layers for learning. So this is the major difference of machine learning. The hidden layers will be more in deep learning. Now you can see the input image. So input image is a room which is having a window, light, tables, bed, etc. This, when you apply the deep learning concept to that input image, so they will be taking many patches. So you can see here, they have taken 4 patches, and each of the patches will be having some set of features. So very basic things are considered as low level features, and you can see somewhat extended region are considered as mid level feature, and the overall object is considered as the high level feature. So all these features are plus the classification will gives you the output. Output is nothing but predicted. So it will predict the exactly. So what's the purpose of deep learning and how it is useful to us? So earlier we have seen that deep learning is nothing but it integrates the classification and the feature extraction part. So it represents a more efficient way to predict a system, and it has to process a large amount of training data. So this deep learning was introduced around 2010 year, and they have outperformed all other machine learning techniques. So initially, deep learning application were mostly used in image processing techniques, and which was called later as computer vision techniques. And deep learning plays an important role in speech recognition and other speech related activities. And nowadays they are using in NLP activities also. So deep learning, it's a more flexible and it's a best framework to represent visual, which is nothing but vision, text, and linguistic information. Representational power. So now we are going to see how the neural networks have been created earlier. So neural network, you can see in our brain, there are many neurons are connected together. So the same concept we have related to our subject also from the mathematical point of view. So the difference between the normal neural network and the deep neural network is, in deep neural network, there will be many layers will be there. It means it is more deep. But mathematically, these deep neural network have the same representational power as like the single layer neural network. Now we are going to see the neural network definitions. So neural network. So here you can consider the input image is the number. So digits. So our objective is we have to recognize the digit present in the left. So what's the number present there? It's 2. So you can identify these numbers from the human point of view, but how these systems are considering. So the best example of this is to detect the digits, handwritten digit recognition. And all these digit recognition images are saved in the database name, which is a popular data set, MNIST dataset. So you can see here the input, the size is 16 into 16 equal to 256. So the first row and the first column element is considered as x1, and there are 256 rows. So x1, x2, 256, x of 256. Now y, output is y1, y2 up to y10. So output will be 1, 2, the last thing is 0. 0 means it's the last element. Now we are identifying the score value. We are giving some score value to all the things. So here you can see for each and every case, we are assigning a score value. So in the score value, if there is, they are assigning the value as like 1 and zeros. So here you can see the score from 1 to 10, the numbers should be there from 1 to 9. So here the score value is 0.7. So since for 2 it is showing 0.7, the image should be 2. So here the same handwritten digit recognition function is doing. Input is 2 image, and this is the machine learning model, and finally we are getting as 2. So elements of neural network. What are the elements present inside the neural network? As I told earlier, it's as like our brain. So many neurons will be there. It will be connecting to each other inputs or output layers. So they are mapped together. Here you can see input into weights plus B, which is nothing but the basic linear classification model, WX plus B. W stands for weight matrix, X stands for input image, plus B stands for bias vector. And it is passing to the activation function. So finally, we are getting the output as alpha. So here you can see the basic function W1 of X plus B1. Here you can see the diagram X. X is nothing but the input layer, Y is nothing but the output layer, and H is nothing but the hidden layer. So hidden layer H equal to sigma of W1 of X plus B1. Output layer Y equal to sigma of W2 into H plus B2. and sigma is nothing but the activation functions. So how many parameters are here? 26 parameters are present here, which means hidden layer is 4 and output layer is 2. So there are 6 neurons are there. And this the 3 into 4 is nothing but input layer into hidden layer plus hidden layer into output layer equal to the weights is nothing but 20 and the biases is nothing but hidden layer plus the output layer. So totally 20 plus 6 is nothing but 26 learnable parameters. So here you can see all the slide credits goes to the college professor. I'm just explaining these contents from my point of view. Okay, so now here you can see the neural network diagrammatic representation. So we are using the Python code and we are explaining using the Tinker. So using this Tinker, just we are displaying the same concept. You can see here data, features, hidden layers. How many hidden layers are there? 6. This is the output layer. 2 input layers are 2. So deep neural network is nothing but they will have more hidden layer. You can see here input layer is 1, output layer is 1. Hidden layer is layer 1, layer 2. It goes on to layer L. And you can see the simple network tie example. 1 minus 1. These are the activation function and this is the weight matrix. Okay, activation function is nothing but a sigmoidal function as like power turn on, power turn off. Likewise, you can consider it. Now you can see the complete diagram of it. So this is a sigmoidal value. Okay, now here you can see the matrix operations. So matrix operations are helpful in working with multi-dimensional inputs and outputs. So wherever you go, you can see the same operation, Wx plus b. Since we have sigmoidal function here, we have to multiply that with sigmoidal function. That is nothing but the activation function. So here you can see input vector and this is the weight matrix W1 and these are the bias vector Wx plus b sigma. So all the matrix operation you can see for each and every layer we have to multiply the sigmoidal function and then Wx plus b. So this is the matrix operation and next comes the softmax layer. So softmax layer it is present as the along with the sigmoidal layer. So Z1 is nothing but the input image, Z2, Z3 are the inputs, Y1 is nothing but the output equal to. Along with softmax layer, you are doing the multiplication. So multiplication layer. So here you can see an output layer. Output layer is Y1. With sigmoidal activation can still be used for binary classification. So here you can see the softmax layers applies activations to output a probability value in the range 0, 1. So 3 inputs are there, Z1, Z2, Z3, and it is added here. This is the softmax layer. So probability value is the Y value should be greater than 1, 0 and less than 1. Next comes the activation functions. So 3 hidden neurons are there. This image has 6 hidden neurons and here it has 20 hidden neurons and these images are taken from the, you can see it is taken from the GitHub website. And next comes the activation sigmoid. So sigmoid can be found here. It takes a real valued number and the value will range from greater than 0 and less than 1. So from the output value 0 and 1, you can understand that if it is 0, it is not firing, and if it is 1, it is firing. So when the neurons activations are 0 or 1, sigmoid values will get saturated. Next, as like sigmoid, another type of sigmoid is tan H. So tan H is nothing but a scaled sigmoid. This is a ReLU. ReLU is nothing but a rectified linear unit. So it takes a real value number and threshold it's as 0. All the deep neural networks, they use ReLU activation. So ReLU, sigmoid, tan H. So there are three different categories, and ReLU is fast when compared to sigmoid and tan H. Now, leaky ReLU. So the drawback of ReLU activation is it can die. So that's the drawback of the ReLU operation. So when a large learning rate is used, ReLU can make the weights to update in a way such that the gradients will value of the gradient will become 0 and the neuron will not activate again. So the neuron is considered as died. So it's a dead neuron. And now the leaky ReLU. Leaky ReLU activation function is nothing but a type of ReLU unit. So this leaky ReLU unit, it has a small negative slope. So most current works, as I told earlier, they are using the ReLU network, which is nothing but rectified linear unit. Next comes the linear function. So here the function is very linear, f of x equal to c into x. So linear function is nothing but the output signal is proportional to the input signal. Now here you can see the training of the neural network. So same digit recognition neural network, then it is passed again to the softmax layer. So before the output prediction, there is a name, there is a layer named softmax layer. Next, data pre-processing. So before applying any algorithm, we have to process the data. So the data, so the processing of that data is called as pre-processing. Under pre-processing, there are many categories. And the first type, this most popular type is normalization. So you know that normalize a signal is nothing but as like a filtering a signal. So you can remove some unwanted values. So you can see here, original data is present in the left, zero centered data in the middle, and the normalized data is present at last. So compare the original data and the normalized data, the many values are filtered. Now we are doing training operation, training the neural network. So to train the neural network, initially set the parameter theta such that the element predicted will be having some maximum values. So you have to make the parameter theta such that the output predicted value will be more. And next thing, we have to define the loss function or objective function or cost function. So here you can see the same digit recognition is passed on to the deep learning network. Then we are identifying the numbers. And here we have to find the loss function. So this structure is helpful to find the loss structure. So here you can see the for the training set of n images, calculate the total loss overall all images. And these are the loss functions. Training examples. Here you can see it is. So training example. Here you can see